What if the universe is hiding something, not in the way a magician hides a rabbit in a hat, but in a far more profound, structural manner? Imagine that the very fabric of space-time, the stage upon which all events unfold, operates not just according to physical laws, but according to rules of information security. This is a radical thought. It suggests that reality itself might be a kind of cryptographic protocol. It proposes that the universe is less like a clockwork machine and more like a secure, encrypted message being constantly written and read. This isn't just a flight of fancy, it's a perspective that emerges when we look at the deepest laws of physics through a new lens, the lens of information, privacy, and proof. Think about the security you use every day. When you use your credit card online, a complex dance of encryption ensures your information is safe. Your computer proves it has the right credentials without revealing your password. The merchant system verifies this proof. This exchange is a protocol, a set of rules for secure communication. Now let's scale this idea up to the grandest stage imaginable. Could the interactions between particles, the passage of time, and the structure of space be governed by a similar protocol? Could the universe be constantly proving its own consistency, verifying its own evolution moment by moment without revealing all its underlying secrets? It's a stunning proposition. To understand the universe as a cryptographic system, we need to identify its key players. In cryptography, we often talk about a prover and a verifier. The prover wants to convince the verifier of something true, for example, that they know a secret password. Now let's translate these characters to the cosmic stage. You could say that any physical system, an electron, a star, a galaxy, is a prover. It possesses a set of properties, its secret, which is its complete quantum state. The universe is a constant, massive dialogue between provers and verifiers. The secret in this cosmic analogy is the underlying quantum reality itself. According to quantum mechanics, the complete state of a system is described by its wave function, a complex, multifaceted entity that we can never directly access in its entirety. The universe seems obsessed with privacy. This isn't just a whimsical observation, it's a direct consequence of its most fundamental laws. Many of the bedrock principles of modern physics can be reinterpreted as features of a robust cryptographic protocol designed to protect information and maintain causal order. Consider causal privacy, the rule enforced by Einstein's theory of relativity that nothing can travel faster than the speed of light. This isn't just a cosmic speed limit, it's a fundamental security feature. It ensures that an event cannot be influenced by another event outside its past light cone. It establishes a secure channel through time, preventing information from leaking from the future to the past and corrupting the causal chain of events. Quantum mechanics introduces its own set of privacy rules, which are even more stringent. The famous Heisenberg uncertainty principle states that we cannot simultaneously know certain pairs of properties, like a particle's exact position and its exact momentum. The more precisely we measure one, the less we know about the other. In cryptographic terms, this is a form of enforced information hiding. The universe will not allow you to extract the complete secret of a particle's state. Even the enigmatic nature of black holes fits this cryptographic picture. The holographic principle suggests that all the information about what falls into a black hole is somehow encoded on its two-dimensional event horizon. The universe uses the ultimate firewall, the event horizon, to enforce different, locally consistent versions of reality, a sophisticated form of access control that prevents causal paradoxes. We often think of time as a dimension we move through, a river carrying us from past to future. But what if time's primary role is cryptographic? What if the flow of time is actually the process of the universe verifying itself? In this view, each moment is not just a point on a timeline, but a complex cryptographic handshake between the past and the present. In cryptography, a hash function takes an input of any size and produces a fixed-size string of characters. The hash. It's a one-way street. It's easy to compute the hash from the input, but virtually impossible to figure out the input from the hash. The evolution of the universe from one moment to the next can be seen as a colossal hashing function. The entire state of the cosmos at time t is the input. The laws of physics are the algorithm. The state of the cosmos at time t+1 is the output hash. This makes the past secure. You cannot change a single event in the past without invalidating the entire chain of hashes that follows. Just like changing one transaction in a single block of a blockchain would create a detectable inconsistency, altering a past event would violate the laws of physics and create a universe that could not have led to the present. Each present moment becomes a verified, immutable record of the past, a transcript of a successful transaction between what was and what is now. If time is a verification process, then, well, space-time itself can be viewed as the ultimate distributed ledger. Think of a blockchain, the technology behind cryptocurrencies like Bitcoin. A blockchain is a decentralized, immutable record of transactions. Each new block of transactions is cryptographically linked to the previous one, creating a chain that is incredibly difficult to tamper with. This ledger isn't stored in one central location. It's distributed across a network, and its validity is maintained by consensus. Now let's apply this powerful analogy to the cosmos. Imagine space-time as a vast four-dimensional blockchain. Each event, every particle interaction, every collision, every decay is like a transaction. These transactions are bundled into blocks, which we can think of as moments in time or regions of space. Each block is causally and cryptographically linked to the ones in its past. This cosmic ledger is fundamentally decentralized. There is no central computer running a simulation of the universe. Instead, the computation is distributed across space-time itself. Every particle, every field, every point in space is participating in the process, constantly updating and verifying its local state based on its interactions with its neighbors. The global consistency of the universe emerges from these countless local, secure interactions. Quantum entanglement is honestly one of the most baffling yet fundamental features of our universe. Einstein famously called it spooky action at a distance. It describes a situation where two or more particles become linked in such a way that their fates are intertwined, no matter how far apart they are. Measuring a property of one particle instantaneously influences the corresponding property of the other. But from a cryptographic perspective, it looks remarkably like a familiar tool. Secure Multi-Party Computation, or SMC. In cryptography, SMC allows multiple parties to jointly compute a function over their private inputs, without revealing those inputs to each other. Imagine, for example, several millionaires wanting to know their average wealth, without any of them disclosing their individual net worth. SMC protocols make this possible. The parties exchange encrypted messages, and at the end of the process they learn the final result, the average wealth, but nothing about anyone else's private data. This is precisely the kind of behavior we see with entangled particles. Consider two entangled electrons. Their individual spins are indefinite until measured. They exist in a shared state of superposition, a private joint secret. Let's say they are entangled such that if one is measured to have spin up, the other must have spin down. When an observer measures the first electron, its spin is resolved. Instantly, the state of the second electron is also determined. The two particles have performed a joint computation. The outcome is correlated and verifiable, yet until the moment of measurement, the individual inputs, the definite spin of each particle, remained hidden. This cryptographic lens transforms entanglement from a spooky paradox into a sophisticated information processing feature. It's a natural protocol for maintaining correlations across space without violating causality. No information is being sent faster than light. Instead, the secret of the correlation was distributed between the particles from the moment they became entangled. Reality uses entanglement to enforce consistent outcomes across its decentralized network, ensuring that the cosmic ledger remains coherent without ever having to broadcast all the private data held within its quantum states. The cryptographic logic of the universe, proof, verification, and the preservation of secrets, may not be confined to the microscopic world of particles. It's possible that this fundamental structure echoes upward through layers of complexity, ultimately shaping the way biological and even social systems evolve. Think about the evolution of symbolic human rituals. From ancient religious ceremonies to modern legal proceedings, humans have developed complex systems of actions and symbols designed to establish trust, verify identity, and solidify group commitments. Consider a tribal initiation rite. The ordeal is the proof. The young warrior must demonstrate courage, endurance, and loyalty. the secrets of their commitment, without simply stating them. Words are cheap. A bloody, painful ritual is a costly, hard-to-fake signal. It's a proof of work. The community acts as the verifier, observing the performance and confirming the initiate's membership. The ritual generates a shared social fact. This person is now a warrior that is securely locked into the group's collective memory, much like a transaction is locked into a blockchain. This analogy suggests that the human brain, having evolved within a universe governed by cryptographic principles, may have naturally developed cognitive and social strategies that mirror this logic. The need to distinguish friend from foe, to verify trustworthiness, and to build coalitions are fundamental survival problems. The solutions we developed, costly signals, shared symbols, and sacred oaths, are all forms of social cryptography. They are protocols for generating trusted information in a world of uncertainty and potential deception. Our capacity for symbolism might be a direct extension of the universe's method for making reality real. From this perspective, the development of language, law, and money can be seen as the scaling up of these natural proof systems. A legal contract is a transcript of an agreement, verified by signatures and witnesses. A national flag is a symbol that proves membership in a vast, imagined community. A banknote is a physical token that proves the holder's claim on a certain amount of economic value, verified by anti-counterfeiting features and backed by the trust in a central institution. These human constructs are not arbitrary. They are sophisticated technologies for creating verifiable shared realities, built upon the same foundational logic of proof and verification that seems to govern space-time itself. Viewing the universe as a cryptographic protocol is more than just a clever analogy. It offers a powerful synthesis, weaving together physics, information theory, and consciousness into a single, coherent fabric. This framework suggests the laws of nature are deeply tied to communication, verification, and secrecy. Reality isn't just objects and forces, it is an ongoing informational process, a secure dialogue between potential and actual. This lens provides new context for our existence. If the universe generates verifiable information, then conscious observers play a special role. Consciousness becomes the universe's most advanced verification engine. Our minds process information, create models, and ask questions. We are not accidental byproducts. We are how the universe probes its own secrets and builds meaning on top of physics. We are the universe's way of knowing itself. This touches the mystery of free will. Our choices influence which quantum possibilities become classical realities. Our decisions are woven into creation's fabric. Our will is not an illusion fighting deterministic physics. It's integral to the verification process, transforming future into past. We are not puppets following a script. We are co-authors of the cosmic transcript. This perspective shows profound connection. The logic securing our digital lives reflects a grander logic securing space-time itself. Principles of proof and privacy may guide galaxies and quantum particles alike. From code protecting our data to laws shaping the cosmos to consciousness contemplating it all, there may be one cryptographic theme. The universe is not just a story, it is a proof being constructed, and we are its witnesses and scribes.
If you guys liked our video and you want to help us out, you want to support us, please consider clicking on our affiliate link for NVIDIA AI, which is the program that we use to create these videos. It's a really helpful tool for someone with no experience to produce a high quality video. You can use natural language and just write in kind of what you're looking for, and it usually nails it. And if it doesn't, you can go back, change the music on each chapter, change every single video clip into a different clip. You can use both generative AI, so it'll produce totally new and fresh animation for you, or you can use stock footage. You can change the narrator's voice for the entire video with just a natural language prompt. Look at specific clips and change each one. You can change the music using the same technique, either just a whole approach with natural language, or you can go in and specifically edit out each. The real value that we found with NVIDIA is just that we don't have any experience necessarily with video editing, but we were able to put together some stuff that we really enjoyed. It was good enough that we wanted to put it out on the internet for you guys. And we're looking forward to using NVIDIA moving forward, seeing what we can do in the future. If you like our video, you like our content, and you would like to support us, please consider clicking our affiliate link and trying out an NVIDIA subscription, and you can produce the same type of quality work with just as little experience as we have.